Okay, it's past 12, which means I can officially say good afternoon, everyone. This is our last talk for the morning session block, and it is my great pleasure to introduce Stephen. Stephen was a data scientist before there were data scientists, with a master's degree in computer science and another in statistics. He spent 15 years owning the engineering and data skills required to do anything a data company, any data thing a company needs. He has built 2 data science teams from scratch and is currently the only machine learning engineer at a small company developing and educating on best practices. Please give a warm welcome for Stephen.
Thanks, everybody, for having me. Okay, let's get started. So, oops. Title, yes, title. A/B testing. These are a variety of NA patterns I've seen in a couple companies, so I just wanted to come run through some of those and kind of chat about A/B testing in general. I've worked with experimentation across companies. The Kelley Blue Book, Thrive Market, they're all at different stages of their experimentation and A/B testing's framework and strategies. And none of these were like fully fledged, running perfectly all the time A/B testing systems. I've never actually seen a company that does that. All I've ever seen are the corner cases and the places where it could be better, right? So I'm going to talk about, what is A/B testing? I'm going to spend some time on that just to be like introduction of like, bring everybody up to a normal baseline of like where that's at. A few anti-patterns, what do we do, and like what does success look like? So what is A/B testing? A/B testing is a process by which 2 or more experiences are measured against each other. It's used in situations where things are changing and we want to quantitatively measure the effect of that change. It's kind of arisen over as a standard practice the past couple decades. You may remember like buying actual software on CDs. We couldn't do that. We couldn't do A/B testing with that kind of software. You couldn't give 2 people a different type of software experience when you were sending them DVDs, nor would you get any measurement back to be able to tell how they were using it differently. So it's really been a web standard the last couple decades for e-commerce and marketing and other types of situations. You're not always interested in quantitatively or quantifiably measuring the difference. That's a key point here. Stakeholders are across the board. Some are like, well, I don't really care if it's better. That's fair. And that's a process by which maybe you don't need A/B testing. So just going to kind of go through a couple examples. Yes, my fabulous visualizations here. Which one is better, right? We don't know. Like we as the programmers, we as a marketing engineer or a marketing professional, we don't actually know which one is better. We don't know which one is going to help people sign up better. We don't know if they do sign up if they're going to stick around. We don't quantitatively know which one is better. We may feel one is better than the other, but A/B testing is a process by which we can actually test that and let users of a website give their opinion, give their vote on which one is better. Similarly, on like recommendation systems, which one of these is better? Is it better to have them ordered in one way or better to have them ordered in another way? We don't actually know the answer to that. And the users of these are a little different. Like the marketing ones, usually marketing engineers, marketing professionals are doing lots of A/B testing on landing pages. In these types of situations, it usually tends to be the data science team. They're pushing really hard to say, we've got to try these 2 different algorithms. We don't actually know which one is better, so let's give it a shot. In this new age of LLMs, we're still doing this. We're still saying, okay, you've started on a website, all you have is a cursor, for example. You still want to have an initial set of preconditions when somebody lands on that page to say, this is the experience you're going to get as a default. Which one is actually better? And the better is different in different situations. Sometimes better is better for the company, more revenue, more clicks, more users coming back. Sometimes it's better for the user, better experience. Depends on the project, depends on the team, depends on the company and the stage and things. They'll kind of go back and forth as to what that actual better metric, better is in that situation for that test that they're running. So what exactly are the requirements? It's not clear generally. Like you'll talk to people, engineers, data scientists, product managers, and they won't actually be able to articulate what an A/B test is or why you're running it. But they all kind of have their own opinions around what it needs. So stakeholders are usually like, I want to give the best experience for the customer, or I want to make the most money. I want to measure the differences between these two things. I want to monitor the experiments while it's running, and I want to make a decision as soon as possible. They all want it to be successful. They want every A/B test to be successful. That's kind of their job sometimes, depending on what that stakeholder is responsible for at the company. There's statistical requirements. So almost universally, like the analytics folks tend to do hypothesis testing. That's one way to do it. Hypothesis testing has a whole pile of statistical assumptions. Fixed sample sizes, random assignments, limiting the data during the test. And you get a p-value, and nobody knows what a p-value is. Like even statisticians are like, I don't know what a p-value is. But they really, one of the core things that they land on generally is they need to know when the user entered the test, when they actually saw the control or the test experience. And that's like a core logging and core knowledge piece that often doesn't get translated into other teams. Then you're actually running a system, right? So you're not just running one A/B test, you're running one A/B test at a time. You're running 10 A/B tests at a time. You may have an old A/B test running and you're like, what was that old test? We forgot what it was. So the system requirements are around like knowing what's actually happening, like which tests are running at what particular time, how are they doing, can we turn them on and off, can we change the percentages, can we make sure people are always seeing the same experience all the time, can we roll out a new test easily. These are all core like system requirements. If you don't have these, it's kind of hard to have A/B testing at all. So then here's some few anti-patterns here. These are actually anti-patterns I've seen. Like I've been to companies, I've talked to people, and I've had these experiences of like, these come up on teams. And if you see one of these, if one of these is around, if it's kicking around to the company, it generally means there's others. And they're hidden and it's hard to say. A/B testing is like a, it can kind of feel like a black box, like you're running this experiments and you get kind of some key ins and outs, and you don't really know what's happening on the inside. But everything's lined up perfectly, it works perfectly, and everything's not lined up perfectly, you get some low quality test, you don't really know what the answer is. And you don't know how it's working without talking to people and communicating with them. And if you see one of these, that's generally an indication that that box is not working properly. So experimentation is a library. Worth pointing out, I've never actually had somebody say this to me, but I've had engineers talk right up to saying this. You know how when you're like talking to somebody and they're like about to say something? I've had people almost say this, and like I can tell what they're going to say, and then they like recognize the audience, they recognize who they're talking to and what the situation is and what they're actually talking about, and then they take a step back and they're like, okay, this is not actually a library. It kind of seems reasonable though, right? You've got people in a test, you can just write some code that does all the wrapping of like putting them in the test, keeping them out, make sure the percentages are right, make sure there's monitoring, do the logging and everything, just have a library and bam, you're done, right? And tests, even if you can keep track of everything, all the different corner cases of like, this test is on iOS, this test is on the Android app, this test is the web. Even if you can track all those and you can have everything working properly, then you're like, okay, well then it's like 3 libraries, right? You've got the web library, then maybe a JavaScript one, maybe there's a server-side one, maybe there's a app, and then you've lost it, right? It's not a library. You're already like building multiple libraries and endpoints and apps and behaviors, and things start to diverge and it gets more complicated. So you have to go back to the basics of being like, what are you actually trying to do? But like since this is a Python meetup, I thought I'd have some Python code. So this tends to be like what engineering teams that I talk to, and engineers, especially like website engineers, front-end engineers, back-end engineers, this is what they think A/B testing is. You import it, sure you need some date time stuff, you get a user ID, you have a default experience, and then you do some like try-catch analysis of like, okay, well if they're in the test, you give them this experience, if they're not in the test, you give them this other experience, if you have some exception, you do some logging and some other default type stuff. Second anti-pattern. All users are in all experiments. I've seen engineering teams that like, okay, you land on the website, you're in the JavaScript page, it's all JavaScript, everything, and we'll just like assign everybody to every to every A/B test experiment when they land on that page, for every page. It's just a default part of the page, just assign everybody all the tests. That seems fine, but then everything kind of gets logged together and everything it flows into the back end, all kind of jumbled together, and you're like, okay, this person landed on the website, sure, but then they got assigned to all these tests, and like, are they still in those tests? Did they see those tests? We don't really fulfill like what the analytics team is looking for, right? They need to know when the user entered the test. And there's ways to kind of pair this together and say, oh, well, they only enter the test if they have the assignment, and then after the assignment, there's like a homepage event or some other event, and you have to kind of line things up properly, and it gets more complicated, right? Like, it's more of a beneficial to say when the person actually saw the test, that's when you're assigning them to the test. Why does analytics need to know when a user enters a test? So the common metric is whether or not like a user is checked out. It's a very common like e-commerce type metric. Based off, if you're doing it based off some experience on the homepage, then the user might add the items to the cart, then the company turns the test on. There could be a delay of like weeks. Like I just will suddenly like pick up my phone and go on a web page and just kind of go to the cart and check out, right? I won't go to the homepage. I'll have the page up already, like the product page or the cart page or whatever. I won't see whatever experience they're running on the homepage, and I'll check out and I'll move on. So from my perspective, I'm a happy customer, but I got assigned to that test. I got logged as seeing the test experience when I really did not. So the best practice is like to think about it like conceptually as a pipeline, right? You've got a user, they're doing some stuff, you're logging some experiences, you turn the experiment on, they're doing some other stuff, you're logging some other things, and then at some point they land on that page, that cart page, that product page, that home page, whatever, and then that's when they're like conceptually, like they're entering the test. We as a company look at them and we say we're going to give them this experience or this experience, the control or the treatment, and from there on we're going to use that to do some analysis to make some decisions on whether or not this user is, or whether or not this metric is going up or down or whatever. They may do some more things. We may collect all that data. We may need that data for the analysis. And at some point, we're going to turn the experiment off, and they can do other stuff on the website, and it's fine. We don't really care anymore. So then we come to the third anti-pattern here. A pile of data dropped on an analyst. There's no discussion. There's no collaboration. There's just, oh, there's a table over here, and we ran this test. Can you do this analysis? In statistics programs, this is common that you'll talk to statisticians, actually like strict PhD statisticians. They're like, nope, I'm not doing that at all. I'm not going to touch that. In industry, they'll be a little more fuzzy, right? But analysts are like, okay, well, we can do something. I've seen analysts just bend over backwards. They've tried so hard to get something out, to get some decision on this test. And they're often judged on whether or not the p-value is less than 0.5, whether or not they can find some noticeable difference. Well, if you put something against the wall and say, find a difference, they're going to find a difference, right? They're going to find something you can use, something the stakeholder can use to say, these are different. And you get a decision, but is that really the best decision? Is that really the highest quality decision you could have gotten? Maybe, maybe not. Is it the easiest that the analyst could have done with that data, with that being presented of trying to come up with an answer here? Maybe, maybe not, right? But it's definitely not like clockwork running and just executing with no real, input. There's a lot of manual input here, right? Okay, so then we land on like experimentation is not a library. It's a cultural system. It's like a more akin to like Agile or something. Sure, you can run an experiment in Android or iOS. You can run an experiment on a web page. You can run an experiment here or there. But like, that's just kind of the way it kind of works. But you have to talk about what it actually is and how you actually want to run that, right? Users only are in the experiment when they actually see one of the experiences, when they see the control or the test, that's when they're actually in the experiment, and that's how they should be analyzed. Please don't drop a pile of data on the analyst. They've got lives. They want to go home at 5 or 6 or 8. They got stuff to do, right? Like, they want to do lots of A/B tests. And so it's better to kind of collaborate and recognize that your team kind of extends beyond just your stand-up, even if the analyst is in your stand-up. Okay, so then what do we do? We get a drink of water. So who owns A/B testing? Well, nobody does. That's part of the discussion here, right? I am going to get back to Python here too. You've got stakeholders and analysts and engineers. Sometimes the finger is pointed at any particular team or any particular individual. Sometimes it's a particular team that owns it, that's presumed to own A/B testing. There's a team of like a product manager, an engineer, an analyst. They're focusing on like web page development or homepage development or something like that. Sometimes it's like they own A/B testing and we don't. Sometimes it's that department owns A/B testing and we don't. It's always we don't. But it's a shared system, right? So we can't have a successful A/B testing program unless there's a collaborative effort between the teams. It's a culture and organization problem. Since nobody owns it, the collaboration and the coordination is really the key to kind of getting everything moving forward, and the automation too, right? What can you automate? What libraries do you need? You don't need, it's not a single library. Maybe you need a couple libraries. Maybe you need a vendor. There's lots of vendors out there. They're all pros and cons, right? If you're going to move at scale, then it comes down to automation. Automation of managing the tests and running the tests and analyzing the tests. Automation of creating the tests and organization to be able to say, this is the test that's running. This conceptually was this test. We ran this test where we made the sign up button bigger. We thought people would be more likely to convert. We ran this test where we reordered the products in the recommendation flow. We thought people would be more likely to convert or to buy more expensive products or whatever. But over time, how or what test was that actually run? So you've run a test today, that's cool. What about the test from 6 months ago? What actually happened there? We've already tried to make the sign up button bigger. How did that go? What actually decision did we make from that? Do we want to try it again? Do we want to try a slightly different test? Maybe we made it too big. Maybe we want to make something in the middle. But if you don't track that and understand that over time, then you won't know that you're rerunning a test that's already been done. So generally, like the product team or stakeholders will own like what tests to run, what metrics are important to them, conversion, revenue. Engineering owns like the bulk of it, right? Like the data flows, the assignment, the UI to be able to turn tests on and off and to be able to change the percentages of people who are seeing a test. And the fidelity, the logging of all the other data you need to analyze the test to come to a decision, as well as the responsibility to have high fidelity logging to be able to say this is actually what happened at this time, and this is how we're going to put all this together because we're collecting all the proper data to be able to do that. Analytics then owns like how to calculate the metrics, how to put everything together on the back end, what the statistical analysis is, hypothesis testing, Bayesian analysis, whatever. That's how they own it, right? And there's a tension and there's a coordination, and that's a good thing, right? But it's not. It's more like agile, right? Like I would guess most people in this room has been on an agile team. You go to stand-ups in the morning. You've got a team of product managers or technical product managers. Sometimes there's an analyst. Sometimes there's a data engineer on the team. It's a collaboration and a connection of people, and that's how we run a project, is from that level of tickets and coordination and working together and giving status. And that's what A/B testing is as well, right? It's a matter of like, how do you organize everybody together to be able to run this test and to have a good, high-quality decision on the other end. This is where you get Python, right? It's just the perfect opportunity for Python to land in a good spot here. It's the marriage of the statistical analysis libraries, data science, statisticians, they all use, well, not all, but Python is a very common language with lots of tools and methods. It's got data transformations, there's lots of engineering best practices, you can do unit testing and deploys and all these other things, APIs. It's accessible too. Like you can give a piece of code to a product manager and they're gonna be able to read through that and say, yeah, that looks basically like what I'm trying to do. It also is accessible to like LLMs. They can read Python pretty easily and be able to produce things that are also readable code that you can understand and see what's going on. This in my mind is like the place where, in my mind, this is why we have conferences like this. Like we talk about like individual pieces of Python, but also we talk about like what types of problems, where it really just kind of has a multiplicative effect on like the users and the implementers in those projects. All right, so then what does success look like then? You go back to your company, you understand anti-patterns, you see A/B tests that are running, what can you actually do? In my mind, the end goal is one A/B test every 2 weeks per team. That may vary by team. There are definitely like knobs and dials there. I've seen teams do every 4 weeks, that's cool. But that's like the goal, right? You want to have small incremental changes that you can test, that you can say, this is actually where we're kind of moving in this direction. Automation. Like lots of Python automation, lots of other automation, always available results, always valid results, an accessible picture of what's currently running. So I've seen teams have inaccessible pictures of what's currently running. Tickets locked in Jira, you don't know which ticket is which, you don't know which tickets are the A/B testing tickets. You don't know why we're running that A/B test. So the picture has to be accessible about what's currently being run, what's actually going on. Jira also tends to be like a flow through. Like I've turned on the A/B test, I closed my ticket, great. How do you actually get an accessible picture of what's currently running? That's a little more complicated, right? I use the word accessible here because it has to be accessible to people who are non-engineers. Every area of concern has some opportunity to improve, right? Product needs to come with small incremental changes that we can actually A/B test. Or like, hey, this big new thing that maybe you don't need A/B testing for, that's cool. Analytics needs to do maybe a little bit less hypothesis testing. It's harder to have always available, always valid results with some types of statistical techniques like hypothesis testing. Maybe they need to do more Bayesian analysis to be able to have that type of methodology to be able to say, this is valid right now. And then they need to work with engineering, like analysts working with engineering to automate this. That's once again, that's the place where Python really shines, right? That collaboration and coordination. So we're back to Python, but this isn't really a Python specific issue. Yeah, these are systems, hey, I already said all this, that's great. These are systems where Python has a multiplicative effect, right? This is like the perfect place where you can have not just build something, but you can build something that's better than you expected to because you chose the right technology, because you chose the right language, because you considered the cultural and the team aspect about what you were actually trying to accomplish and how it was all going to work long term. So if you're on a team and you kind of have one of these anti-patterns, maybe it's a symptom that like your A/B testing is not up to the high quality it can be. Generally, I've seen this just be on like newer or smaller teams. More established teams are a little bit better at like trying to keep track of some of these things and trying to have that understanding that it's a cultural collaboration coordination issue. So doing better means like recognizing the cultural aspect, seeking clarity, trying to make sure that you understand what the test is, what it's being run, why you're running the test, what was the test last week, what decision did we make, and aiming for better and just kind of talking to people about what A/B test is running, what's going on, what you're actually trying to accomplish. So I wrote all these slides a while back, and then I wrote LLM slides, because that's the world now. Can't we just have an AI do all this? It's once again, this isn't a technical problem, right? It's a cultural people documentation problem. An LLM could definitely help with like understanding past tests. If a team has a reasonable set of documentation, like this is a test we've run, that would be a fabulous piece of documentation to throw into an LLM. Hey, we've run all these tests, what should we do next? Hey, we've run all these tests, and now I'm going to run this test. Is there something I'm missing? Is there some metric I should include in my test? Is there some, is it already similar to a test we've already run? What do we expect to get back? It's also worth pointing out, like I believe we are definitely at a pivot point. The world is definitely changing. Software engineering is changing. Everything needs to be re-examined from the ground up. Do we actually need A/B testing? I think that's a core question around, do we need user interfaces? Are we actually trying to quantitatively measure incremental change? If we're not, then definitely not. If you're not like changing things to the user, if you're not trying to quantitatively measure incremental change, you don't need A/B testing, and that's fine. What does an organization value? Does your organization value incremental small changes to show what direction you're going or not? And that's okay too, right? Like there have been successful companies that have been stood up and been very loud and clear that we don't do A/B testing, and they have been successful, and that's an okay route to go. I've also seen companies do that and then reach a point where they're like, oh no, we gotta do some more A/B testing. It helps you measure if you're on the right track. That's really the main point of like, you're in a forest, are you going the right direction? This is what helps you check on that. Thank you so much for listening today. Thank you so much to the organizers of the event, and this has been a wonderful experience.